Hey guys, good morning. Um, just to kind of catch you guys up, so today today is Tuesday, so we're going to do the notes on molarity and dilution. So finish up kind of the basic solution notes. After notes, you will have time to work on your part 1 homework that's due tomorrow. Ideally, you might actually be able to finish it during class today because it's 10 problems is what deals with today, and then that's the end of the part 1 homework. For tomorrow, we are doing a lab. We're doing liquid capacity of a penny. So we'll kind of do what we did with the last lab where everyone will be split into their different groups, and we'll have one group streaming to the people at home. So your part 1 homework is due tomorrow. The lab we're doing tomorrow will be due on Thursday. That way, if you need a couple more minutes to kind of answer those analysis questions, you can. And then we're going to start in on acids and bases on Thursday. And remember, you guys are going to have a quiz on part 1, which is what we did yesterday and today. You'll have a quiz on that Friday. So that gives you a chance to ask me questions before then on any of the concepts. I think that's pretty much everything for this week. We'll go ahead and switch over. You do need a calculator handy. So whether you pull one up on your computer, you have one available. And I think I told you guys, all of the math for this unit is formula-based. So everything has a formula you kind of plug in and solve for X. So it's no kind of new math concepts that you've never done before. So it shouldn't be terrible. So we are going to start off and we're going to do molarity and dilution. So molarity is going to be referring to the concentration of a different substance. So concentration is the measure of the amount of solute that is dissolved in a given quantity of solvent. So this actually looks at how much of whatever the chemical is dissolved in water or dissolved in the substance. So actually measuring how much is dissolved overall. Solutions can be deemed either dilute or concentrated. So dilute solutions are solutions that have a small amount of solute. So these don't have a lot dissolved in them. So they're going to be very weak overall. Whereas we have concentrated solutions, so these are solutions containing a large amount of solute. So you might make drinks this way, or a lot of times cleaners. Sometimes we buy cleaners in kind of the large jugs, and then they have the spray bottle that you pour a certain amount in, add water to it to dilute it. What you would buy in the big jug is the concentrate. There's a lot in a very small amount. So you only need a small amount to actually clean everything. So that's why you kind of water it down overall and dilute it. There are things like you can make orange juice from concentrate and things like that, where they have all the orange pulp and everything, and then it's added to water and kind of mixed together. That's kind of another thing where it's the concentrate, where it's a lot in a very small space, and then you water it down to dilute it. So whenever we're looking at molarity, so this is going to be our calculation that's going to tell us how concentrated a solution is. So this is going to give us an actual number value. So molarity is represented by a capital M, and it looks at the number of moles of solute dissolved in a liter of solution. So this is actually on your reference sheet, is this formula of the molarity, the capital M, and I'm just rewriting it because it doesn't let me type it very nicely, is moles of solute over liters of solution. So I just retyped that second, or rewrote that second bullet. And the liters is the amount for the entire solution, not just the solvent. So if we had 500 milliliters of water, and once we added the solute to it, it's now 505 milliliters. Yeah, we would use that 505. So the total volume once everything is put together. And generally, this is something that you would have seen on our solution bottles and things that we use in lab. So like for certain substances, it might have like 1 m or like 0.1 m. So this is just a 1 molar solution. So that means that there's 1 mole per liter if it's a 1 molar solution. So this is something that you are going to have to calculate. And like I said, this formula is on your reference sheet. It does need to be in moles. So if it gives you grams, you have to change to moles before you can plug it in. It also has to be in liters. So if it gives you milliliters, you have to change to liters before plugging it in. So make sure that you have the correct unit before you plug in to try to solve for molarity. Here's what a molarity problem would look like. So here we have intravenous or IV saline solutions are often given to patients at the hospital. One saline solution contains 0.90 grams of sodium chloride in exactly 100 milliliters of solution. And we want to know what's the molarity of the solution. So this first one is actually probably one of the hardest because it gives you grams and milliliters. But in order to solve for molarity, we need moles and liters. So we're kind of going to have to convert everything into the correct units before we can plug in for molarity. This is not using any new math skills that we have not done at some point in time. So what's given to us is there's 0.90 grams of sodium chloride in 100 milliliters of solution. So we said for molarity, we need moles on top. So we're going to have to change from grams into moles. So remember, that's our kind of one-step stoichiometry calculation. So 0.90 grams of sodium chloride. We said we need to get to moles, so we don't need grams anymore. So where should that go in our next step? Yep, down to the bottom. To change into mole. And remember, grams per mole is always out of 1 mole. So grams per mole is that molar mass. So sodium is 22.99 plus chlorine is 35.45. So that's 58.44 grams per mole. So that's going to allow grams to cancel and leave us with moles. So we're going to do the 0.90 divided by the 58.44. So this is 0.015 moles. So that's going to be our number that goes on top for molarity. So I'm just going to kind of write that over to the side. So 0.015 moles. And then, so molarity is moles over liters, but it gave me 100 milliliters. So remember, milli, those are our metric prefixes. So if you remember way back in Unit 1, we did the King Henry died by drinking chocolate milk. So remember, liters is a base unit. So we're going from milliliters to liters. So that means we have to move the decimal back to the left 3 spaces. So if we move it to the left 3 spaces, that's going to be 0.1 liters. So now that we have moles and liters, we can just plug that in the calculator to solve for molarity. So we would do the 0.015 divided by 0.1, and we get that this is 0.15, and the unit for molarity is just that capital M. So it's 0.15 molar sodium chloride. So that means that if we had a full liter, we would have 0.15 moles in a full liter of the solution. So that was probably one of the harder molarity problems because you had to change both the grams to moles and the milliliters to liters. Hopefully, overall, it's not bad, not terrible. All right. And I got a couple people writing, so let me give them a moment. And then we'll go on and do another one. Let's look at this one. We have a solution that has a volume of 2 liters, and it contains 36 grams of glucose. If the molar mass of glucose is 180 grams per mole, what's the molarity of the solution? So remember, molarity is moles over liters. So looking at what it gives us, it does give us that we have a volume of 2 liters. So that's going to go on the bottom. And then it gives us grams of glucose. Well, we need moles of glucose. So this is where we can do that one-step stoichiometry. And we need to change from grams into moles. So remember, we start with grams. I'm just going to do this down below. So 36.0 grams of glucose. And I'm just going to abbreviate it. It did tell us the molar mass of glucose, so we don't actually have to find it. So we need to get rid of grams. So that needs to go to the bottom of our next step to change into moles. And we said, remember, this is grams per mole, so it's always out of 1 mole. So it's that 180 grams in 1 mole. That's going to allow grams to cancel, leaving us with moles. So we have to do the 36 divided by the 180. So that's 0.2 moles. So that's going to be our top number in our molarity equation. So then to find molarity, we have to do the 0.2 moles divided by 2 liters. And that gives us 0.1 molar is our molarity. Sorry, I circled it and the decimal disappeared a little bit. So overall, the math isn't terrible. It's kind of plug in, solve for X, but it's making sure that you have the correct units before you plug in. So make sure that you have moles and make sure that you have liters. Sometimes it will give you moles and liters, so you don't have to do any of the extra conversions that we've done so far. You can also use molarity to solve for either moles or liters. So you can kind of rearrange to solve for different variables in our equation. So let's look at this one. Here we have household laundry bleach is a dilute solution of sodium hypochlorite. Wants to know how many moles of solute are present in 1.5 liters of a 0.7 molar sodium hypochlorite. And we are dealing with molarity, so remember molarity is moles over liters. So this example, it's wanting moles. So we're looking for that top unit that we don't have. It gives us that we have 1.5 liters of solution, so that's our bottom value. It also gives us our molarity is the 0.70 molar. So to solve for moles, we have to get it by itself. So we just need to multiply by the 1.5 on both sides. So then we'll have the 1.5 times 0.7 is going to be 1.05 moles. So just be aware that you may not always be solving for molarity. You can use that same equation to find moles. You can also use it to find liters. It might even ask you for grams. So once you find moles, you have to change into grams, or it could ask you for milliliters. So using those same conversions that we're doing. All right, how are we feeling about molarity? Thumbs up, thumbs down? Good? Okay. Okay. So the other part of what we can do with molarity is we can perform dilutions. So diluting a solution reduces the number of moles of solute per volume, but the number of moles of solute is the same. So you're not actually taking away any moles, you're just adding volume to make the overall molarity decrease. So we can actually calculate how much we should dilute a solution to get a new molarity. Like I said, if you go to the grocery store and sometimes you'll buy, especially if you shop at like Sam's or Costco, a lot of times they'll have kind of the large jug of cleaner and then the small spray bottle. So you just have to add some to the spray bottle and add water to dilute it. The big jug of cleaner might be too strong to use on all of the surfaces in your home and things like that. How we actually dilute something is using this dilution formula, and this is also on your reference sheet. This is just, it took the molarity formula, and since moles was the same, rearranged it to kind of get a comparison to molarity and volume. So we have the beginning molarity times the beginning volume is equal to the final molarity times the final volume. So it's this M times V equals M times V. This is something that I do on a weekly basis whenever I'm setting up for lab and stuff. Whenever we order chemicals, a lot of times acids and things like that, like we get 12 molar sulfuric acid. I'm not about to give y'all 12 molar sulfuric acid. That's way too strong. That would burn your skin and things like that. So what we do is we dilute it to make it maybe a 1 molar solution. That's going to be much safer to use. But I have to know exactly how much of the 12 molar solution I need to make a 1 molar solution. So I have to know how much to measure out to dilute with water to get that new concentration, to get that new molarity. And I'm just making sure everybody's with me before we go on to the examples. All right, so let's look at this one. Here it wants to know how many milliliters of an aqueous 2 molar magnesium sulfate solution must be diluted with water in order to prepare 100 milliliters of an aqueous 0.4 molar solution of magnesium sulfate. So how you can kind of tell if it's a molarity problem versus a dilution problem. Dilution, you're going to have 2 of the same unit. So you're either going to have 2 molarities or 2 volumes. Whereas molarity problems will have molarity volume, but then it'll have something regarding moles or grams. You're only going to have 1 of each unit with molarity, whereas dilution, you're going to have 2 of the same unit. So this, because it's asking for volume molarity, we know it's that M times V equals M times V. And sometimes the hardest part is figuring out what 2 numbers pair together. So kind of use your context clues as you're reading. So it wants to know how many milliliters. So it wants to know the volume of a 2 molar solution. So these 2 numbers should go on the same side. Those go together. And it doesn't matter whether you put them on the left side or the right side, as long as they're paired up together. So we're looking for the unknown volume whenever our molarity is 2 molar. And it tells us we are diluting it with water to make 100 milliliters, so that's a volume, of aqueous 0.4 molar solution. So those are going to go together. So our molarity on the other side is 0.400 times 100 milliliters. And you can leave it in milliliters as long as it is milliliters on both sides. So you don't necessarily have to change to liters as long as your units match. So to solve for volume, we're going to have to kind of simplify this side and then divide by 2. So you can do this all in one kind of calculation. So we're going to do the 0.4 times 100, and then divide by 2, and that should be 20 milliliters. Since our volume on the other side was milliliters, this will also be milliliters. So dilutions are actually a little bit easier than molarity calculations, kind of math-wise. Like I said, the hardest part is figuring out what things go on the same side together. So kind of use your context clues. Let's look at another one. So here it wants to know how many milliliters of a solution of 4 molar potassium iodide is needed to prepare 250 milliliters of a 0.760 molar potassium iodide. And we're using the same formula of the molarity times volume equals molarity times volume. So kind of figuring out what's going to go on each side together, and wants to know how many milliliters of 4 molar is used. So those go together. So we're going to have the 4 molar times an unknown volume. And it says that's needed to prepare 250 milliliters of a 0.76 molar solution. So that's going to be our other side that goes together. The 0.760 molar times 250 milliliters. So same kind of deal. We have to isolate volume. So we're going to have to divide by the 4 on both sides. So if we put this in the calculator and we do 0.760 times 250 milliliters divided by 4, we're going to get that our volume we would need is about 47.5, and our volume unit was milliliters. So how are we feeling about dilutions? Thumbs up? Good deal. So like I said, the math isn't particularly hard. There are formulas for everything, but it's kind of making sure that you have the correct units and plugging in. Remember, for math, always show your work. So even if you show me the setup and you don't show me I did this times this or this divided by this, as long as you have that general setup, that way you know what to do mathematically, that's okay. But don't just write an answer down. All right, and I think that was my last slide. So that's all that we're covering today, is the math for molarity and dilutions. So let me pull up on your homework so you can continue working on part 1 homework. You can actually finish it. We've done everything for it. So remember, the beginning of the part 1 homework was the solubility curves we did yesterday. That was up through number 6. And then where you have the underlined heading, the molarity and dilutions practice, you have 10 molarity and dilutions problems. Like I said, make sure to show your work. You probably don't have room to show it on here, so just do on a separate sheet of paper. Remember, you don't have to write questions and all of that stuff. Some of you guys are spending extra time writing questions when you don't have to. If you really want to, that's okay. But you only have to do number 1, show the setup, and solve. Make sure, remember, every number should have a unit. So if you're solving for molarity, it needs that capital M with it. If you're solving for moles, just write moles. If you're looking for grams, write grams. So make sure to have your number and your unit with everything. You guys have the whole rest of the period to work on this. So you can probably finish this within the period and go ahead and turn in your homework. It's not due till tomorrow, But we're pretty much going to use the whole class time tomorrow to do our lab. So you're not going to have a lot of work time tomorrow. So be mindful of that. My guys at home, as soon as it hits 7:30, we're starting. So make sure that you're kind of logged in on time tomorrow, even a couple minutes early if you can. That way you don't miss any of the lab data. Other than that, my guys at home, I will let you go. I'll stay logged on if you have any questions. But go ahead and work on this and get it taken care of.